Okay, welcome to today's class. In our last video, we had a class on LCM of numbers. Okay, so today we are going to look at LCM of algebraic expression. So we have LCM of algebraic. So this is what we are going to look at today. Let's divide our board into two. Okay, now when we say algebraic expression, what are we talking about? Example of algebraic expression. Example of algebraic expression. Okay, so we have something like s square, we have something like x, we have something like mn, we have something like 3s square y, we have something like s plus y, s plus 1, okay, in brackets. We have something like x square plus y square. Okay, all these are examples of what algebraic expression. Okay, so we are looking at how can we be able to solve or find the LCM of an expression like this. Okay, so what are we going to do? Let's take an example. Find the LCM of 3s square y and 15xy square. Okay, so we have 3s square y and 15xy. Okay, sy square. So how can we find that? Let's have our answer. We just like what we did in LCM of numbers. Okay, we are also going to do that in LCM of algebraic expression. Okay, so and what is that? Keep dividing the expression till you get one. And of course, when you have there's s here, there's s here, but the power of s here is higher than the power of s here. So we use the highest power to divide. You use the highest power to divide. So in the case that I have s square here and I have x here, what am I going to do? I will use s square to divide. When I divide s square there, I will have what? Okay, let's do it one step after the other. Let's go with the numbers first. 3 can go here, 3 can go here. So I will use 3. I will have what? S square y. When I go 3 by 15, I will have 5s y square. So there's still a number here, which is what? 5. So I still need to divide this by 5 so that I can be able to have what? The expression now left. So I'll have what? Divide by 5. I have s square y because there's no 5 here to divide. So here will give me what? Um, Here will give me sy square. Okay, so I will now go with uh the alphabet, the variables, okay, which is x square and y, s and what? Y square. So the shortest way to go about this is when you have an expression, you go with the highest power. Okay, for this s that have s square, so I'll go with that s square because that's the highest power between s square and s. The one that have the highest power is s square. So I'll go with the s square, which will definitely going to give me y, and this one will give me what? Y square. Now, why is this method easier? Because I don't need to do this s 2 times. I can just do it once so that I can be able to eliminate it immediately. So I have s square, so s square will go here. Of course, this one s, which this one have already covered. Okay, so I have y here, I have y square here. The highest power of the variable y is what? Y square, the one that have power 2. So I will go with that one that have power 2. That will give me 1 and 1. So our LCM is now 3 times 5 times s square times y square. So that will give us 15s square y square. So that's the LCM of 3s square y and 15sy square. Let's go to example 2. Example 2, let's have a mixture of algebraic expression and a number. So we are going to say find the LCM of 35 and let's go with 5s um 5s square m. Okay, 5s square m. So in this case now I have 35, which is a number, and 5s square m, which is an algebraic expression. So we have our answer. We have 35 into 5s square m. Okay, like I said before, you can see that 5 can go here, 5 can go here. Okay, so when you use 5, you have what? 7 here, 5 here will give you 1. So I have s square m. So you go with 7. 7 is 1 here, s square m. So you can see that just like what we did here, that we use the highest power, okay, of s to divide instead of going with s and another s, we can as well do that here. Okay, since 5 is 35 is can be divided by 5. Okay, I can as well go with 35. You can see the product of the two numbers that we have here is already 35. So I can as well from the beginning go with 35. Since 35 can 5 can actually divide 35, so it's not going to have any form of any effect on it. But we have already done this one, which is still okay. So we are done with our numbers. Now let's go to the variables. The variables we have is s square, so 1m, then m, that will give us 1, 1. So the LCM here is 5 times 7 times s squared times m. So that will give us 35 s squared m. Okay, so that's our answer there. Okay, let's look at when we have algebraic expression that is in the bracket. Okay, an algebraic expression that is in bracket. So let's get our duster. Let's take for instance that this is our example 3 to find the LCM of s plus 1, s squared plus 1, and x. Okay, so we want to find the LCM of an algebraic expression of this nature, which is an expression in bracket. Of course, we have the one that is not in bracket. What are we going to do? It's the same thing. So we ask ourselves, do we have anything that can divide all these? Okay, is there anything that we can use to divide this that can also divide this that can also divide this? Okay, remember, when you have an expression in a bracket, okay, when you have an expression in a bracket, it is seen as a single number, is still in a unit. Okay, so you cannot just come and divide this s here, no, because s plus 1 is a unit, is like one number, so you cannot separate them. Okay, s square plus 1 is as if it's a unit, one number, so you cannot separate them. So as you can see, there's nothing we can use to divide everything, so we have to divide individually. Okay, so how can we do that individually? Let's start with s. That will give us back our x plus 1. Then s here will still give us our s plus 1 because it's a unit, so you cannot divide from the bracket. Okay, you cannot use this to divide just one part of it because it's combined with 1, so it's like a unit. Okay, but when s divide this one, we have 1, so we are going to do the bracket the same way. So we have 1 here, we have s squared plus 1, then we have s squared plus 1 here, we have 1, 1, 1. Okay, so when you do what we have been doing, which is to multiply the factors or the product we have there, or find the product of what we have here. So that will give us s into s plus 1, s squared plus 1. Okay, so you can see that in a situation where there is no common multiple, the LCM is just the product of the numbers. What does that tell you? LCM of 3 and the 5 will give you 3 times 5 because there is no common multiple or there is no common factor. Okay, LCM of 7 and 8 will give you 7 times 8 because there is no common factor. Okay, so that's how to deal with our algebraic expression, or how to find the LCM of our algebraic expression. We can still solve one more example, or you can go back to your textbook and pick some question on LCM of algebraic expression, attempt them, first see if there will be any challenge. Remember to leave a comment in at the comment section, and like our page and share our page. Help us grow this page because we are going to look at most of the topics in mathematics, though one step at a time. Thank you.